Hello everyone, welcome back to our channel Problematical. Today we'll start with miscellaneous exercise of chapter 1 sets from class 11th maths NCERT. So in the first question, you have to decide among the following sets which sets are subsets of one another. So there are 4 sets A, B, C and D mentioned. What we'll do is we'll convert them into roster form, the ones that haven't been converted. So the first one is in set builder form. A is a set of all x such that x belongs to R, that means x is a real number, and x satisfies x square minus 8x plus 12 is equals to 0. If you consider this equation, x square minus 8x plus 12 is equals to 0, this is a quadratic equation in degree 2. Obviously, quadratic equation is degree 2. So you can split 12 to get an addition of minus 8. 12 is 6 into 2. So by our shortcut method, x minus 6 and x minus 2 are the factors, minus 6 minus 2. This is how we split the middle term. And x value is either 6 or x value is 2. X is equals to 6 or 2. 6 and 2 are real numbers and they satisfy this particular equation. There is no other number which is a real number which satisfies this equation. So this is your roster form. B is already given in roster form, 2, 4, and 6. C is given as 2, 4, 6, and 8. All even numbers. And D is given as 6. So let's start with D because D is a singleton set. So we know that D is the element 6 is present in every other set. So we can directly say that D is a subset of A. D is a subset of B and D is a subset of C. Next, if you consider C is the biggest set and it won't be a subset of any other set. B contains 3 elements. Now A and D contain 2 and 1 element respectively. So definitely all the elements of B, 3 elements, will not be present in A or D. 2, 4, 6 are even numbers. They are present in C. So we can say that B is a subset of C. A has 2 elements. Definitely A is not a subset of B because D has a single element. 2 and 6 both are present in B as well as C. So you can see that A is a subset of D and A is also a subset of C. Next. In each of the following, determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. So, first statement. If x belongs to A, that means you are considering a set A and x is an element of A. Amongst the different elements, x is an element of A. So let x over here be, we are assuming x is a variable, it can have multiple values, but just for the simplicity of the statement and to understand the statement, we are considering x to be a single value, constant value, say 1. So 1 belongs to A. That means our first condition, if x belongs to A, is satisfied. X belongs to A and x belongs to B and A belongs to B. It means that B is another set and A is an element of it because belongs to has element on the left hand side and set on the right hand side. So A is an element of B. You can have other elements of B like 3 or 5. It can also be written as in its true form by defining A in set B itself. Still, in both these scenarios, this is your 1 element, 2 element, 2nd element, and 3rd element. Then x belongs to B. Now x is 1. In the first case, 1 is not present. In the second case also, 1 is not present as an element. It is present as a part of element, but it's not a complete element. So x here, 1 belongs to A, but 1 does not belong to B. Here, this is false. Now, it was asked, in each of the following, determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. So, an example, you can mention any random values. You can consider A as any set. Let A is equals to 1, 2. B is equals to A comma 3 comma 5, which is equals to 1 comma 2, 3 comma 5. Here I'll consider any element. Here 1 belongs to A and A belongs to B. And means both the conditions on the left hand side and right hand side of the word and are true. Here 1 belongs to A and A belongs to B, but the same element 1 does not belong to B. Therefore, the statement is false. Second, if A is a subset of B and B is a subset of C, and B belongs to C, then A belongs to C. Let's see if this is true. A is a subset of B. So let's consider a set A to be 1 and 2, and B be another set which contains 1, 2, 3, 3 values. So here we can clearly say that A is a subset of B because all the elements of A are present in B. Second, it's written that B belongs to C. So C is another set and B is an element of it. So B, 4, 5, 7. B is an element of it. Then A belongs to C. Does A belong to C? Does C contains 1 and 2 as elements? No, it contains B, 5 and 7 as elements. So again, the statement will be false. We have to give an example. We can give the same example. We can consider this as example. Here, A is a subset of B and B belongs to C, but A does not belong to C. A is not an element of C. Third, if A is a subset of B and B is a subset of C, then A is a subset of C. Let's consider A to be a singleton set 1, B to be a set 1, 2. It's said that A should be a subset of B. Definitely A is a subset of B. Furthermore, you want B to be a subset of C. So all the elements of B should be present in C. Right? Here, then A is a subset of B. C. If this is possible, then all the elements of A will be present in C. So A has a single element 1. It is present in C. Definitely the statement is true. Now, when the statement was true, you were supposed to prove it. Not give an example, but actually prove it using the set's properties. So let's try and prove it. It's given that A is a subset of B and B is a subset of C. Let's consider an X element which belongs to A. Then, since A is a subset of B, let X belongs to A. Therefore, we can say that X also belongs to B, since A is a subset of B. If X belongs to B, then X will also belong to C, since it's given that B is a subset of C. The same element which was present in A is present in B because A is a subset of B, and the same element is present in C because B is a subset of C. We know that X element belongs to A, and now we are saying that it belongs to C. So we can directly say that A is a subset of C because X can be any element of A or all elements of A. So A is a subset of C. Therefore, next. So with this, we found out that first is false, second is false, third is true. Next. If A is not a subset of B, now consider another example. A is not a subset of B. So let A be a set of two elements, 1 and 2, and B be a set of say 1 and 3. So all the elements of A are not present in B. 2 is an element in A, present in A, and 2 does not belong to B. B is not a subset of C. So all the elements of B are not present in C. C can be anything like 1, 5. So again, 1 is present over here, but 3 is not present. Then A is not a subset of C. A is not a subset of C. Now in this scenario, it is easily found that A is not a subset of C. Can you have a scenario like this in which this case is false? Let's see. Let A have A is 2, 1, 2. So C can be something like this: 1, 2, and 5. Here, A is not a subset of B because 2 is present in A and 2 is not present in B. B is not a subset of C because B has 1 and 3 elements in it, and 3 is not present in C, so B is not a subset of C. Then A is not a subset of C. A 1 and 2 elements are present in C. So here A is a subset of C, which means that this statement is not always true. Even if you find a single situation where your given statement is not true, then it will always be considered as false. So if you have 99 scenarios where the situation is true and one scenario in which the statement is false, still you'll consider it as a false statement, in which case you are supposed to give an example. We'll consider the same example. Here, 2 belongs to A, but 2 does not belongs to B, which says that A is not a subset of B. Secondly, 3 belongs to B, but 3 does not belong to C. Therefore, we can say that B is not a subset of C. But 1 belongs to A, 1 belongs to C, and 2 belongs to A, 2 belongs to C. Therefore, A is a subset of C. Hence, the statement is false. Next, X belongs to A and A is not a subset of B. X belongs to A and A is not a subset of B. These are given. If this is the scenario, then X belongs to B. Then X belongs to B. Now let's consider examples for this. X is an element of A. So let A be a set of 2 elements, 1 and 2, and let us consider X to be 1. A is not a subset of B, so B can be any set. So let's consider 3, 4, 5. All these numbers are not present here. Then X belongs to B. Not necessarily. X is an element which is 1, and it's clearly mentioned that A is not a subset of B. Therefore, this 1 is not present over here. You can consider another situation in which your A is 1, 2, and your B is 1, 3, 5. Again, X is equals to 1, and 1 belongs to A. So X belongs to A, and A is not a subset of B since 2 is present in A but not present in B. So both the situations are there, but here your X element 1, your 1 belongs to B. So here with this kind of example, the situation is false, and with this kind of example, the situation is true. We found a situation in which the statement was false, so we'll consider it as false. So let's write the example. Here for this particular situation, here let A be equals to 1, 2, B be equals to 3, 4, 5. Let here, okay, let X is equals to 1. 1 belongs to A. A is not a subset of B since 2 does not belong to B, but 2 belongs to A, and 1 does not belong to B. this is a situation for A not being a subset of B. So 1 belongs to A, but 1 over here does not belong to B, which means your X, which was 1, does not belong to B. Hence, the statement is false. Next. X is a set A. Hold on. So, A is a subset of B and X does not belong to B. Then, X does not belong to A. Let's consider a scenario where A is a subset of B. A is equals to 1, 2 and B is equals to 1, 2, 3. We have the condition that A is a subset of B. X does not belong to B. Now, apart from 1 to 3, you can consider X as 4. Then, that X does not belong to A. Definitely, 4 is not present in A. This is valid for any value of X that you consider. If it is not present in B, it will definitely not be present in A, since A is a subset of B already mentioned. So, this is true. We'll have to prove it. This is your fifth. This is your sixth question. It's given that A is a subset of B and X does not belong to B. This is given. Let consider X instead of X. Let's consider Y. Y belongs to A. You have considered an element in A. Therefore, Y will also belong to B, since it is given that A is a subset of B. Right? Now, you have an element X which does not belong to B. If X does not belong to B, then X does not belong to A. And this is based on the definition itself. So, all you have to do is write this much and it's sufficient. Because an element, because the reason being A is a subset of B. Or you can write it in statement, X does not belong to B. Therefore, X is an element, or let's write the definition of subset. By A subset B, we mean that all the elements of A of A are present in B. Or no element not present in B will be present in A. So negation of negation, which means no element. ऐसा कोई भी element नहीं है which will not be present in B, which is not present in B. B will present होगा, that will be present in A. There is no element which is not present in B which will be present in A. But some of the elements of B can be A, or all the elements of B can be A if it is a superset. So by this definition, we can say that X does not belong to A. Next. Let A, B, C be the sets such that A union B is equals to A union C and A intersection B is equals to A intersection C. Show that B is equals to C. Whenever you are supposed to prove two sets to be equal, there are a few ways to do it, but the common way to do it, or one of the most popular way to do it, is through subsets. That means if you have to prove that A, B is equals to C, set B is equals to set C, then we know that by definition, if B is a subset of C and C is a subset of B, then B is equals to C. So two conditions over here are present. If both these conditions are satisfied, then we can directly say that B is equals to C. So to prove B to be equal to C, we have to prove that B is a subset of C and C is a subset of B. So if you're able to prove these two conditions separately, then you can easily say that B is equals to C. So let's prove them. If you have a if you draw a Venn diagram for two sets A and B, then we can say that this portion is the intersection of two sets, and all the area covered in both the sets A, B, their intersection, this dotted part, this dotted part. So both the dotted regions and the shaded region combinedly forms A union B. Now, with this information, we'll consider to prove that we first prove B is a subset of C. So let us consider an element X which belongs to B. If this element belongs to B, then you can easily say that it belongs to A union B, because if it is in this dotted region, we can by observation, by basic knowledge, say that it will definitely be present in A union B. Therefore, X element is present in A union B. Now, in the question, it is given that A union B is equals to A union C. So by default, we can say that it is A union C. It also is present in A union C, right? If it is present in A union B, and in the question it is given that A union B is equals to A union C. So you can say that it belongs to A union C as well. Now, whenever you write something like A union B or X belongs to, say, X union Y, this means that union. Now, union is referred to as OR. So you can say that X belongs to capital X or small x belongs to capital Y, by understanding as well as a way to express it. Similarly, for further reference, if you have an element Y which belongs to X intersection Y, then it is referred as X belongs to a capital X and means as well as so your Y belongs to capital Y. This would be your understanding of intersection and union as far as proofs are concerned, and this is how we express it in words. So here we'll express this in words: X belongs to A or X belongs to C. Now, for B to be a subset of C, you need an element X which belongs to B to also belong to C. Now here X is belonging to B, and you're ending up with two situations, either this or this. So X belongs to C, it's fine with us, but what if the X belongs to A? So we'll try and solve this X belongs to A further. Okay, so when you say that X belongs to A, you've come to a conclusion that X belongs to B. Like we started your proof from X belongs to B, and now you're saying that the same element belongs to A. For the time being, we'll only focus on X belongs to A. So you're saying that X belongs to B, and now you're saying that X belongs to A. We know that if it is and in the middle, we can write it as intersection, which means X belongs to A intersection B. From the question, it was given to us if A intersection B is equals to A intersection C. So you can say that X also belongs to A intersection C. Intersection means X belongs to A and X belongs to C, which means X belongs to both of them. So definitely we can say that by this conclusion and this conclusion, and we started over here by these three conclusions, we can state that X belongs to B and X belongs to C, which means that X belongs to, B is a subset of C. You can say that X belongs to B union C, B intersection C, or you can say that B is a subset of C, because every element which was B, present in B, will definitely be present in C according to this explanation. Next. One second, yeah. Now let's consider an element which is present in C, because now we are trying to prove this part. Let's consider an element Z which is present in, which belongs to C. If this element is present in C, then this element will also be present in, with C we have A union C, A union C, A united with C. Similarly, this element will therefore be present as in A union B, because A union C is equals to A union B given. If this is true, in words it is written as X belongs to A or X belongs to B. If it is present in X belongs to A or X belongs to B. Now we need this B. So B is fine. If it belongs to B, fine. But what if it belongs to A? So let's further solve it exactly the way that we did before. We are solving this part further. We are continuing it. Someone said that, we said that initially Z belongs to C. And now we are saying that Z belongs to A. In which case here Z belongs to A and means intersection C. By the given value, A intersection C is equals to A intersection B, which means X belongs to A, Z belongs to A, and Z belongs to B. Means from this and this, from first and second equation, we can say that C is a subset of B. Let this be third equation, and this is your fourth equation. From 3 and 4, you can say that B is equal to C. So this is from 1 and 2. From 3 and 4, we can say that B is equals to C. Next. Show that the following 4 conditions are equivalent. When you say that they are equivalent, we have to prove that condition 1 is equivalent to condition 2, is equivalent to condition 3, is equivalent to condition 4. By equivalent, we mean that if you consider the first element as given part, you can easily say that the second element is, you can prove the second, third, and fourth elements, and vice versa. You can consider any element as given element, given condition, and you can consider the other equations as to prove part. And you can do that. You can easily prove the other set of equations. Let's consider first and second, and let's try to prove first condition is equivalent to the second condition. So in this case, your given part would be A is a subset of B, and you have to prove that A minus B is equals to 5. So either you can do it by considering an element, or you can do it by contradiction. So by contradiction, what you'll do is we'll try to prove, if possible, suppose A minus B is not equals to 5. Like this is what we are assuming, the opposite of what we are supposed to prove. This is the process of contradiction. We use the process of contradiction to prove certain statements that are fairly basic to the definition. Now, A minus B is not equals to 5. That means there exists an element. Therefore, there exists an element. Let's consider X, which belongs to A. And if you say that A minus B is not equals to 5, that means it's not a null set. That means after subtracting B elements from A, you're left with some element in B. This is what you mean. that when you take all the elements of A and you subtract B elements from it, that means you remove the common elements from it, there is at least one element left behind, which means your set A minus B is not equal to 5. X belongs to A, and that element should not belong to B, otherwise it will be removed. And that same element is not present in B. Okay? This is what you are saying when you say that A minus B is not equal to 5. But it is given that A is a subset of B. A is a subset of B states that all elements of A are present in B. That is, if X belongs to A, then X belongs to B. Now, this is your given condition. This is an extended version or further explanation of your given condition. So from 1 and 2, A minus B is not equal to 5 is not possible. That's why we started this statement with if possible, if at all it is possible. We'll see whether it's possible or not. And we came to a conclusion that it is not possible. Therefore, the opposite of it should be possible, which means A minus B should be equal to 5. Because if A minus B not equal to 5 is wrong, then A minus B is equal to 5 should be correct. This is the method of contradiction where you have came to a conclusion that your first A is equivalent to second condition. Next. Now let's try and prove whether the second condition is first condition with second is done. Let's try and prove first condition with third. First condition with all three. Let's prove those. So here your given part would be A is a subset of B, and with this you're supposed to prove that A union B is equals to B. So when you say that A union B is B, with A union B, proof. With A union B, you can say that okay. यहाँ पर we'll go with this method. A union B is equals to B. Let's see if you can prove that it is a subset or not. Let's consider an element in. I know I'm not making any sense. Hold on. Let's consider an element in A union B. So this particular element belongs to A. Union means or this particular element belongs to B. Let's try and see this part. What happens if X belongs to A? Now we know that A is a subset of B. So if X belongs to A, X will definitely belong to B according to the condition that A is a subset of B. Right? That means if this X is an element of A union B, the same X will also be an element of B. Either it's an element of B, and after solving A, we also came to a conclusion that the element is present in B. Therefore, A union B is a subset of B. How can you prove that two equations are equal? If you can prove that first is a subset of second and the second is a subset of first. So we have just proved that first is a subset of second, or the LHS is a subset of RHS. This is your equation 1. Now let's consider an element belonging to B. What happens then? If the element is belonging to B, then that element will also belong to A union B. Because this is by definition, right? If you have an element in one set, then A union B, or uniting that set with any other set, the element will be still present over there. So definitely B is a subset of A union B. This is 2. Now to avoid confusion, let's consider another element apart from X. Yeah. So from 1 and 2, we can easily say that A union B is equals to B. Therefore, your first condition is equivalent to your third condition. Now let's try and prove the first condition. Okay, by these two conditions, like first is equivalent to second and first is equivalent to third, so you can easily say that first is equivalent to second is equivalent to third. So all three conditions, first, second, and third, are equivalent to each other. Now, let's consider this as, I'm going to give it capital 1, Roman number 1. Okay. Sorry, 1 second. Yeah, this is first condition. This is second condition or second equivalence of conditions. And now we'll consider first and fourth. First is A is a subset of B, and fourth is A intersection B is equals to A. This is given, and this is what you're supposed to prove. So again, you have to prove that A intersection B is equals to A. So you can consider an element X which belongs to A intersection B. And if an element X belongs to A intersection B, then X belongs to A and X belongs to B. It's given that X is a subset, A is a subset of B. So any element which is present in A, which will also be present in B. Or here X was belonging to A intersection B, and you came to a conclusion that here X belongs to A and X belongs to B. That means X belongs to both A and B. So definitely A intersection B is a subset of A. Now let's consider the other way around. This is 1. Another element Y which belongs to A. If an element belongs to A, then this Y belongs to what can be there? Anywhere where A is present. If X belongs to A, then what? A is a subset of B, then X also belongs to B. If X belongs to A, this is because A is a subset of B. If X belongs to A, Y belongs to A and Y belongs to B, then we can say that Y belongs to A intersection B. If this is true, then we started from here, Y belongs to A, and we ended up with the same element presenting A intersection B. A can be considered as subset of A intersection B. This is your equation 2. Shouldn't have same numbers over. You should consider 3 and 4. From 3 and 4, we can say that A is equals to A intersection B. You started with A is a subset of B, or you used A as a subset of B, and you came to a conclusion of A is equals to A intersection B. That means you proved that first condition is equivalent to fourth condition. First condition is equivalent to fourth condition based on this conclusion. This can be considered as your third. From 1, 2, and 3, we can say that the condition 1 is equivalent to condition 2 is equivalent to condition 3 is equivalent to condition 4. Now, this is the symbol for equivalence. Now, equivalence, where your left-hand side contains a condition. Condition can be anything like an inequality, or an equation. And your right-hand side is also, or can be in the form of an equation. So you cannot have like more than 1 equals to, it couldn't be an equation. Equation is you have an LHS and RHS, hence the word equivalence. Next. Show that if A is a subset of B, then C minus B is a subset of C minus A. Now the given condition is A is a subset of B. To show C minus B is a subset of C minus A. So let us consider an element X which belongs to C minus B. So whenever we are supposed to prove something is a subset of something else, you always take an element on the left hand side of that particular condition. So you're considering an element in C minus B. Now, if you have an element which belongs to X minus Y, you write it in words as the element should belong to X and the element should not belong to Y. So we'll write this as X belongs to C and X does not belong to B. Or you can consider this as Z belongs to the Z minus X minus Y can be written as X intersection Y dash. Intersection is and Y dash does not belong to Y. So X belongs to C and X does not belong to B. Now it's given that A is a subset of B. So if there's an element which is not present in B, the element will definitely be not present in A because A is a subset of B. Since A is a subset of B, therefore X does not belong to A. If there's an element which does not belong to A and there's an element which belongs to C but which does not belong to A. Now X belongs to C and X does not belong to A. So we can say that X belongs to C minus A. Because the reversal, if this is true, then this is true. We started with this, we ended up with this, so we can say that C minus B is a subset of C minus A. Next, assume that power set of A is equals to power set of B. So it's given power set of A is equals to power set of B. To show that A is equals to B. This is what you're supposed to show. Let us consider an element in A. X belongs to A. Now X belongs to A and we know that power set of A will definitely contain A. Any set will be a subset of itself and power set is a set of subsets of a particular set. So A is a subset of itself. Therefore, A belongs to is an element of power set of A. But we know that power set of A is equals to power set of B. So we say that A belongs to power set of B. Since power set of A is equals to power set of B. Now you have an element in you have A in the power set of B. So, once again, so if you consider any other element in the power set of B, then can you say that X belongs to that C? X belongs to A. You started with X belongs to A. And now you're saying that your A is present in the power set of B. X is an element in A and A is present in the power set of B. So you can say that X belongs to B. The power set of B contains a number of elements. And these elements has one such element which is your A. So definitely this particular B set will contain the element X that we initially started with. By this knowledge, we can say that A is a subset of B. because the same element which was initially present in A is now present in B. Next. This is your condition 1. Now, let's consider Y, which belongs to B. So you're considering an element which belongs to B, and using the same argument. I mean, since you're giving the same argument for an element in B as well, you can definitely use similarly. So you can write similarly, B is a subset of A. This is your second condition. So from 1 and 2, we can say that A is equals to B. Is it true that for any sets A and B, power set of A union power set of B is equals to power set of A union B? Justify your answer. Now, giving a justification is equivalent to proving a statement if it is at all true. If it is false, give an example, and that would be the justification of a false statement. So they're asking you if it is true. We'll try and prove it. If we can prove it, if we come to a conclusion, if you're able to prove it, then the condition is true, else the condition is false. In which case, obviously, the example. So you can prove it by using proof, which is given in your example part of your text. You can use the similar version of it, the 31st question, I guess. Or you can try it by an example, like considering A and B to be a particular sets. So let's try it with an example this time. Let A is equals to 1, 3. B be another set which is equals to 3, 4. Therefore, we have to make use of A union B. So A union B will be equal to 1, 3, 4. Okay. Now let's try and find the power sets of A. A has 2 elements. Number of elements in A is equals to 2. So number of elements in B in power set number of elements in power set of A will be equal to 2 to the power 2, which is 4. Power sets of A, all the set of all the subsets. So phi is a subset, singleton sets 1 and 3, and then you have A itself 1, 3. These are the elements of power set of A. Similarly, power set of B will have 3 singleton set, 4 singleton set, 5, and the set itself 3, 4. Again, number of elements in B is 2, number of elements in power set of B will be 4. Power set of A union B. This is equals to 5 singleton sets 3, 4, set 1, 3, 4, and dual sets. A set which contains 2 elements. Not dual sets, but set which contains 2 elements. 1, 4. Now, A union B contains 3 elements. Number of elements in A union B is equals to 3, and number of elements in power set of A union B will definitely be equal to 2 to the power 3, which is 8. Here you have 1, 2, 3, 4, 5, 6, 7, 8 elements. Left hand side is power set of A union B. So uniting these two, power set of A union power set of B will be equal to 5 is common, singleton sets 1, 2, 3, 4. 3 is present in both, so written only once, 1, 3, and 3, 4. So when you united these two, you got only 6 elements. So definitely there are 2 elements which are present in power set of A union B, but which are not present in power set of A united with power set of B. This means your given statement is false. Power set of A union power set of B is not equals to power set of A union B. So with justification, we directly started solving with the help of an example, and the justification is valid. Now, if you were to solve it by the other method, which is like to equate to conditions in sets, we have to say that the LHS is a subset of RHS and the RHS is a subset of LHS. So you won't be able to come to a conclusion. Like even if we start with the LHS, you won't be able to prove that the LHS is a subset of RHS or not, and vice versa. Next, show that for any sets A and B, first condition and second condition. That means no other information is given, and we have to prove that A is equals to A intersection B union A minus B. So what we'll do is we'll take the RHS A intersection B union A minus B. We'll solve it and see whether we come up with your LHS or not, because LHS is concise. It's a single variable, single set named A. A intersection B union A minus B can be written as A intersection B dash. So now this looks like here you can apply distributed property A intersection common. So you can say that A intersection B is left behind united with B dash. Now any element united with its complement will give you a universal set. So you have A intersection universal set. Amongst universal set and A, you are intersecting it. So the common elements will be present in A. This is equals to A, which is your LHS, hence proved. In the second part, let's start with LHS. A union B minus C. This is equals to A union B minus C can be written as B intersection A dash. This is equals to A union B intersection A union A dash. This is A union B intersection A union A dash is equals to U, universal set, and A intersection A union B united, common between this and universal set is A union B itself, which is your RHS. So here in this case, you started with your RHS and you ended up with your LHS. In the later stage, you started with your LHS and ended up with your RHS. Now this is proving something by using properties of a set rather than its definition on considering elements in the set. So to prove something, there are ideally 5 standard ways to do it. One, by using a Venn diagram. Draw a Venn diagram and see whether the conditions on the LHS are equivalent to those of RHS. If you draw a Venn diagram for your LHS and that is equivalent to the Venn diagram of your RHS, then you can say that that means the shaded portion are same, and you can prove the LHS equals to RHS. Second, by using this method, which we used in 8th question, which is using the standard set properties. And like distributive properties used over here, A union A dash is equals to universal set, intersection definition of union, all those are used. Then third method is by using examples, which we did in the last question, 7th question. We used examples, we used some values of the elements for particular sets, and thereby proved whether the condition is true or false. Next, we have the method that we used in the previous questions, like 4th, 5th, and 6th, where we considered elements of a set and thereby proved whether the conditions are true or not. And 5th is by contradiction, which we used in the 4th question particularly. We used contradiction in all the 3 parts to prove whether something is true or not. We are assuming what you're supposed to prove is false and thereby coming to a conclusion that the assumption is wrong.